Okay, so here it says 90% of MBAs from UCLA find a job within 3 months of graduation. And it says assume that everything's independent and things like that. Okay, so the probability that any one person finds a job is 90%. And then part A says find the probability that at most 7 out of 10 will find a job in their chosen field. So we've got n is equal to 10, and we've got x is equal to at most 7. So at most 7 means 0, 0, 1, 2, 3, 4, 5, 6, or 7. Okay? Now if you think about it, the number of total outcomes is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 11, not 11, just 10. Okay, if 10 people go searching for a job, it's possible that all 10 of them find jobs. It's possible that 9 or 8 or 7. It's also possible that 0. Okay, so there's 11 possible outcomes. All right, so at most 7 means we can go to our probability table, and we're going to look up n equals 10, p equals 0.9, and x equals 0. And when I look that number up in the binomial probability table, this says I get 0 plus, which basically means almost 0, but just ever so slightly over 0. And actually, and so the probability of getting 0 is close to 0. Probability that only one person finds a job is almost 0. Probability that only two is almost 0. Probability that only 3 people find a job is almost 0. Okay. The probability that only 4 people find a job is almost 0. The probability that 5 people find a job is 0.001. The probability that 6 people find a job is 0.011. And the probability that 7 people find a job is 0.057. Okay, so probability of getting at most 7 is I would add all of these numbers up, and I'd have 0.001 plus 0.011 plus 0.057, and that number adds up to 0.069. Okay, so at most 7 means the probability of getting 0, 1, 2, 3, 4, 5, 6, or 7 people finding jobs. Okay, and so I would have to add the probabilities taken from the table of each of those outcomes. And the probability, if 90% of people are finding jobs, and the probability where only 1 person or 0 people out of 10 people find a job, that probability is almost 0. And so the table shows that it's practically 0. And so you can add these up and you get 0.069. For the next part, it says, what's the probability that at least 8? Okay, so n equals 10, and x is at least 8. So that means 8 people find a job, 9 people find a job, or 10 people find a job. And if we go to our probability table, again looking n equals 10, p equals 0.9, and x equals 8, 9, and 10, the numbers that I get for that are finding 8 people, with 8 people getting a job is 0.194. The probability that 9 people find a job is 0.387. And the probability that 10 people find a job is 0.349. Okay, so if I add those numbers up, 0.194 plus 0.387 plus 0.349, this is equal to 0.93. Okay, 0.930. And the last part, it says find the probability that anywhere from 7 to 9 out of 10 will find a job. This is 7 to 9 inclusive, so that means we're looking for n is equal to 10 and x is equal to 7, 8, or 9. Okay, And one thing you'll notice about parts A and B is that they are complements to each other. All of these numbers probably add up to 0.001, okay, but when you add all of the numbers up, it's supposed to add up to exactly 1.0, but just because of some rounding issues with the table, it comes out to be 0.999 instead. Okay, but here now we're looking for the probability of getting 7, 8, or 9. So using the table, the probability of getting exactly 7 people finding a job is 0.057. The probability that exactly 8 people find a job is 0.194 using the table. And the probability that exactly 9 people find a job is 0.387. So these are, we're asking what's the probability of getting 7 or 8 or 9. So we're just adding them up together, okay? Now the rules for adding probabilities, you're supposed to subtract off any overlap, but there's no overlap in any of these situations, so we don't have to worry about subtracting any overlap, okay? If you think about it, if 10 people go out searching for a job, it's impossible to have a situation where 7 people and 8 people have found a job. Either 7 people have found a job or 8 people have found a job. You cannot have a situation where both 7 and 8 people have found a job. It's either the outcome is a total of 7 people have found a job or 8 people have found a job. So there's no overlap between 7 and 8. So that's why we can just add these probabilities up. So these, we're just looking up numbers in the table and we're adding them together, and that shows our probabilities for the binomial problems.